Good morning. It's Mr. Sadler coming to you live from the internet. It is, what day is it for you guys? It is MCF. Today is Thursday, the 13th of December. I just found out today I'm going to be gone the whole rest of this week. I will be back next week. So what I plan to do today is I'm going to do a recap of some of the algebra stuff you should know in this course. I'm going to do a little brief thing on that difficult trig that Cal and Marissa and Holly were complaining to me by email from Monday, to make sure that's clear for you guys. And yeah, tomorrow I'm going to go on a little bit more for trig, but not too heavy duty. Because I understand this is one of the more difficult concepts of the year. So today's going to be a bit of review and a little recap from solving for sine and cos from Monday. Okay, so today's going to be called is just solving equations. That's going to be our title today. And we're just going to do examples. Solve 0 equals 3x squared minus x minus, we'll say 14. Alright, so I'm going to start with, actually one thing I should mention before I move on here is that some of the supply teachers have been mentioned to me that not a lot of work has been done by my first period class, which disappoints me greatly. You guys, my other class went mad when they hear this, so hopefully they don't. But you guys have been probably my best class for the whole year, and I like you guys a lot as a class. You've got a lot of work done. I'm very proud about how you guys, most people in the class, have done here so far this year. So when I hear things like that that things are out of control when I'm not there, it very disappoints me, because that never happens. I never hear, as I mentioned before, other teachers have told me things about some of the students, and I haven't seen any of them in this class. You guys have been awesome this year, so stick with it here again for the rest of this week, and I'll be back there for Monday. So we're going to solve this equation. Now, there's two ways to solve this. Number one is factoring. The second is quadratic formula. I'm going to solve, it says solve either by factoring or quadratic formula. Either one will work. Okay, what I'm going to do today is I'm going to use the quadratic formula method, just because I want you guys to get used to it again. So x is going to equal, actually I'm going to pick on someone at random. That's Riley. Riley, can you recite the quadratic formula for me, please? Okay, great. Negative b. Keep going. Okay, plus or minus the square root of b squared minus 4ac all over 2a. Wonderful. Excellent. Tremendous even. Sage, can you tell me what a equals, what b equals, and what c equals, please? A equals 3, b equals -1, c equals -14. What I'd like the supply teacher what I want the supply teacher to do now, please, is to hit pause on the video and give the kids a chance to try this one out. And once you're done, yeah, then we'll take it out. Okay, great. So here we're back here. Now, what you may have been saying as you went through this is that these solutions were beautiful. Mr. Sadler, why didn't we just factor this one? And you could have factored this because the numbers happen to work. I wanted to give a quadratic formula one that wouldn't be too messy. So Liam, I'm going to get you to be brave and sub the numbers in here for me right now. Okay, good. Liam, you remember that negative b is plus 1, or just 1. Excuse me, I'm feeling great here. Plus or minus the square root of -1 squared minus 4 times 3 times -14 over 2 times 3. Excellent. Good. Alright, Nicole, since I know you love these videos so much, can you please tell me what -1 squared is, please? Let me repeat that. -1 squared, good, is 1. Can you also please be brave and tell me what -4 times 3 times -14 is, please? Actually, I'll have to get out my calculator to confirm your answer. 4 plus minus times 3 times 14 plus minus is 168. Now remember, for Nicole and everyone else here, that changes to a positive because you have negative 4 times 3, which is still a negative, and then negative 12 times negative 14 will change to be positive. Now I can do that. 1 plus 168 is just going to be 169. So that equals 1. Whoops, what happened here? I need to see my playlist. That equals to 1 plus or minus the square root of 169 all over 6. Okay, good. All right, Connor, can you do the square root of 169 for me, please? Good, that's 1 plus 13 over 6. Therefore, 1 plus or minus 13 over 6. Oops. Okay, great. So that would mean either x equals 1 plus 13 over 6 or x equals 1 minus 13 over 6. So x equals 14 over 6, whoops, which is 7 over 3, or, whoops, x equals negative 12 over 6, which is negative 2. Okay, so as we're going through this here, the question is, do I need to bring the lowest terms? Yes, of course you do. All right, we'll definitely have to do that. Okay, so the first type of questions you'll have to do for tonight's homework will be quadratic formula. So I want to make sure you can do that. Example 2 here will be, and by the way, supply teacher, if I'm going to quickly give the kids a chance to catch up, so feel free to hit pause. If somebody doesn't understand something, let them ask the class. And most of this stuff, except for maybe example 3 and 4, the class has seen a million times, so there should be, some people should remember how to do it. So example 2 is going to say solve. We'll say 1350 equals 12 times 1.8 to the n. Alright, so this one here is going to involve logarithms. Excuse me. The reason I know that is that we have a variable in the exponent. Right? So, first step here, Jennifer, is going to be what? Okay, very good. Divide by 12. Okay, the reason is we do that is because you need to have over here just one thing on the left and one thing on the right before I can do the next step. When I divide both sides by 12, I get, whoops, you don't need to see that. Playlist again, I don't know why it keeps coming up. 1350 divided by 12, which should be 112, whoops, 0.5 equals 1.8 to the power n. So what I did there was I divided both sides by 12. Okay, what I'm going to do now is get the supply teacher to hit pause, and I want everyone in the class to solve this. It should take about 2 minutes, is what you should give them. Matt Andres is who's going to give me the answer here, hopefully in a second. Now remember, there's an n in the exponent, so we'll go ahead, hit pause. Okay, and continue. Okay, so as soon as you see an n in the exponent, Matt, we're going to do what? Hope you said hit log, so log 112.5. I keep forgetting if we did log or ln. I think we did log, so I'm going to write log. So for there's that. Alright, Will, I want to get n by itself. So how do you do that? Okay, hopefully what you said is log 112.5 divided by log 1.8. Whoops. And we've done enough of these. Hopefully this will come back to people. Kim, can you please calculate that? Where did my thing go? Please calculate that for me, please. So 112.5 log. Where's my log button? So there we go. Divided by 1.8 log, and then equals. I got 8.04. Okay. Okay. Now before we move on. Excuse me. Before we move on to our last two examples here, I just want to go through some of the rules. I think this is what the confusing part was. If you remember when we started this unit, we did those unit circles on the board where we did sine, cos, and tan. Our three rules we discovered were this. We're going to say when solving for theta, the solutions are, for sine, your answers are theta and 180 minus theta. For cosine, the answers are theta and 360 minus theta. And for tan, the answers are theta and 180 plus theta. Okay, so we will, you'll have to use these a lot throughout the rest of this course. So those are 3 things to remember. And we did these, I'm trying to remember what day it was. Could have been Thursday or Friday last week. Okay, and we did the unit circles on the board and all that stuff. Okay. So we can do this just with calculations here too. So I'm going to start with example 3. And hopefully this will help clarify some things. I know this wasn't that clearly explained on Monday. Example 3, I'll go to the next board here. Excuse me. Once again, example 3 says solve 0 degrees is less than or equal to theta is less than or equal to that. What this means is that my answers, I only want answers from 0 to 360. If you remember, we're talking about periodic functions. When we did the graphs earlier in the week, we had arrows on both ends. Remember, we said the domain was anything. Okay, and we're just going to do 3 quick examples here, then we'll get to some difficult algebra. So A is going to say sine theta equals 0.4. I can't remember who I stopped at. I think Kim did the last one, so I think we're at Sharnika. Sharnika, if this is back in grade 10, how would you solve for theta? What would we have to get rid of on the left-hand side? Oh, goodness. Sorry about that. Okay, so what hopefully you said when I was having a coughing fit there is you said theta equals sine inverse 0.4. Okay, right, so we're just going to move the sign across there. And hopefully Sharnika and everyone else got that to equal 23.6 degrees. Oops. 0.4 inverse sine was 23.6 degrees. Okay, all this new thing that we learned last week is this, and this was supposed to be Monday's lesson. All we learned is the other angle, since we're using sine. There's a second angle for theta. Oops. Theta is also equal to 180 minus 23.6. So theta equals 157.4, I think. And if you don't believe me, I'll just prove it to you right now. If I do sine of 23.6, so I'll do 23.6 sine, and I get 0.4003, which is pretty darn close. If I do sine of 157.4, what happened there? 57.4. Don't tell me to do 180 minus 23.6 wrong. 156.4, yes I did. I was wondering why that didn't match. If I do sine of 156.4, and I hit sine of that, you should also get the exact same thing. If you remember, this is because sine is the y value on the unit circle. Okay, that's the reason for that. Okay, we're going to do the same thing with cos and tan here right now. Okay, letter B. If you're not comfortable with this, just go with it for right now. It'll hopefully clarify as we continue on today and the rest of the year. So cos theta we're going to say equals 0.1. We're up to Hannah. Hannah, how do you go to the cos, please? Good. Oops, cos inverse. Okay, good. And Jake and everyone else in the class is hopefully going to give me the cos inverse of 0.1. 84.3 degrees. By the way, for everyone in the class, if I'm going too quickly and you need the supply teacher to hit pause, please let me know. I'm sorry, I'm feeling like crud, as you can probably hear. So just bear with me here on this if you can, okay, for this. So we're going to cos inverse to get that. So we're going to say then for, so since using cosine, Conrad, what's my second angle going to be? If my first angle is 84.3, my second angle, I'm going to use this. Okay, so it's going to be theta equals 360 minus 84.3. And you get theta equals 275.7. And again, just as a test before, cos 84.3 should be 0.099319, which is close to 0.1, and 275.7 cos should be okay. And the reason for this, once again, is that cos is the x value on the unit circle. Alright, so there's sine and cos. We do the same thing for tan, then we're going to pick a slightly more complicated one, and then we're going to call it a day, and I can go to bed because I'm not feeling great. By the way, this isn't 9 o'clock a.m. when I'm recording this one, like you guys are viewing it. Tan of tan of theta equals negative 0.4. Okay, so I'm going to move up to Cody. Now, Cody, it should be 9:30 now, so hopefully you'll be walking in here right now. And if he is, you can give him a hard time, whoever the supply teacher is, for being late. Okay, so we're going to say theta equals what? How do you get rid of tan? Tan negative, whoops, it should be negative 1, negative 0.4. So we're going to say then that theta equals negative 0.4, we'll inverse tan, and we get negative 21.8 degrees. Now I see a little problem with this, but I'll deal with my problem in a sec. Negative 21.8 degrees isn't going to work for us, but we'll talk about why that's a problem. I'm going to go to Nick. Since we're using tan, what's my second angle going to be? Good, it's going to be 180 plus negative 21.8, which should be 180 minus 21.8, 158.2. And just as a test here again, tan of negative 21.8 equals tan of that is negative 0.3999, and tan of 158.2 should also be the same thing. Okay, so I made a problem here, so I'm going to say it one more time. A tan is the slope on the unit circle. Alright, so I made a slight problem with this. The problem that we have is this angle right here. I'm gonna bring this down. I'm gonna say this is negative, which we don't want. So we're gonna say whenever I'm gonna do this over here so it's related. Whenever an angle is negative, add the period 360 to make it positive. So my other angle then is going to be theta, and I'll hope to do this on the unit circle if I can, equals 360 plus negative 21.8. And that should be, let me bring this up here, 338.2. And hopefully if I do tan of 338.2, get the same thing. Now, where's my paint? I don't paint up anymore. Sorry, excuse me here. Okay, I'm going to open up paint here for a sec. And sorry, I'll go back to this if you're still copying it down here. But what I just want to show you briefly on the unit circle is why that is. Oh, excuse me. So here's my beautiful unit circle, sort of like this. Okay, in red I'm going to do a nice line that shows me negative 21 degrees is somewhat like this. Okay, if you remember, this is 0 and it's going around positive like this. So this is a negative 21 degree angle. In green then I'm going to use, whoops, no, this should be red. Oh goodness, what happened there? I'm so smooth, you know that. So there's red, good. I'll go to green here now. Green will be, this is my second angle, I forget what it was. This is 158.2, I should probably write in here. So in red, this is going to be negative 21.8. Okay, and that's going to be going, is going to be going like this. Okay, in green, the next angle is going to be sort of like this, and that's going to be, what did we say, it was 158.2. Where'd my text go? Okay, now the problem here again is that you only want positive angles. So there's positive 158. To get back to this one, it's going to be the same as, I'll do this one in blue now. The blue line, find the line here. The blue line should look sort of the same as that. It should exactly be the same thing. But instead of going clockwise, it's just going to go counterclockwise like this. And that number right there should be 338.2. Okay, hopefully that'll help clarify things. The idea is if you want two angles to be the same, they have to have the same arm on the unit circle. That brings it back to the circle. And this is also going to relate to graphs a little bit too. I don't want to scare you guys too much though with the graph, relating the graphs to the algebra, but that's what we'll be doing here fairly soon. Okay, so there's that. Excuse me, I'll give you one final example and then you guys got tons of work to do for the rest of the period. I'm going to say solve. I'm just going to copy this from 0 to 360. And the question is just going to say 5 equals 3 cos theta, we'll say plus 1. No. Plus 4. Okay, so let's just pretend this is just a plain old algebra question. I forget who I'm at. I want to say it's Thomas though, so I'm going to pretend it's Thomas. Instead of calling that cos theta, let's just pretend that's like 3x plus 4. So Thomas, if you want to solve 3x plus 4 equals 5, what's the first thing you have to get rid of? Well, yeah, clearly it'd be this, right? So you do 5. I'll change this to red if I can. Oops. Minus 4. This is almost as good as a smart board. Actually, it's not even close, but that's okay. Equals 3 cos theta plus 4, and then back to red. Minus 4. I'll scroll down a little bit so those at the back can see. Okay, great. Alright, Kilty, 5 minus 4 is? Good, 1. So I'm going to say 1 equals 3 cos theta. Okay, great. Callan, if that was 1 equals 3x, what would you do? Good, you divide by 3, so it changes 1 over 3 equals cos theta. Matt, if I want to get theta by itself, what do you need to get rid of? Good, the cos, so I'm going to say cos inverse. Oops. Of 1 over 3 equals theta. Alright, who am I at here right now? Holly, can you do cos inverse of 1? Oops. Can you do cos inverse of 1/3 for me? pretty good. 70.5. 70.5 degrees. I'll call that a degree. Okay, hopefully that shouldn't be bad. The tricky part is getting my second angle here right now. And I'd like some superstar, since we're using cosine, to tell me what the second angle is going to be. So if the first angle is 70.5, the second angle is going to be what? That second superstar is going to be Marissa. Cosine means 360 minus. Very good. Oh goodness, sorry. That's 289.5. Okay. So if you type in either of those angles, either of this one or this one, you should get an answer that works. Alright, so for the rest of today's class, there should be a piece in a second here on the website. There will be a excuse me, not a coughing fit. There will be a not a choice time, but just homework to do. Okay, so I've listed three. Sorry, excuse me. I listed I think 9 questions to do. Oh, I'm sorry. 3 are quadratics, 3 are logarithms, and 3 are sinusoidal. So if you can try them out here right now, play along. They are only of this difficulty, the example 4. Hopefully example 3 and 4 help clarify things. If you need the teacher to go back to here when I'm solving them, feel free. I'd recommend writing these someplace you can see them for right now to get used to solving them. And yeah, we'll go from there. Okay, thanks guys. Have a good day.